Hey guys, welcome back to Conceptual Geometry. Today's lesson 1.4 is on vertical angles and parallel lines. So first let's talk about vertical angles. What are they? Vertical angles are opposite angles formed by intersecting lines. So that's what they are. Probably the most important thing to remember about vertical angles is that they are always equal. Very important. So in this diagram, the left, angles 1 and 3, so I'm going to mark those, 1 and 3 are vertical angles, and angles 2 and 4 are also vertical angles. So in this diagram, we know that angle 1 is equal to angle 3, and that angle 2 is equal to angle 4. All right, so let's take a look at a few examples. In example 1, we have to identify what angles are given to us. So I have this angle, and those are indeed opposite, and they're formed by intersecting lines, so I know that they are equal. So my equation is pretty straightforward. 2x minus 4 equals 28. All right, some simple algebra here. Add 4 to both sides. 2x equals 32. Divide by 2. X equals 16. And the directions just say find the value of x. That's all we have to do. We are done. So my next example, it says angle 1 is 2x plus 9, so they're referring to this one. Find the measure of angle 1, but they also give us the vertical angle. So again, notice that these are opposite, therefore they're going to be equal. So I've got 5x minus 21 equals 2x plus 9. Now this might be the first time we've seen this type of equation in this course this year. My variables are on different sides of the equation. So what I need to do is I need to get the smaller one, that's my recommendation, and move it to the other side. So that means I'm going to subtract 2x from both sides. That gives me 3x minus 21 equals 9. Now I just need to get this, move it to the other side. So I'll do the opposite, add 21. That gives me 3x equals 30, divide by 3. And I've got x equals 10. Now notice this is not the answer. It wants us to find the measure of angle 1. I know x is 10. It says measure of angle 1 is 2x plus 9. So what I need to do then is just take 2 times 10 plus 9. I would just throw that in my calculator in one shot. That gives me 29. And that's the answer to this example. All right, so now this looks a lot more complicated. All right, I don't just have one pair of vertical angles, kind of like I did here. I could just set those two things equal. Now I've got a whole lot going on. I do have vertical angles. I actually have 3 pairs, and I also have a lot of straight lines. So remember, anytime you have a straight line, that equals 180 degrees. So I know all of these angles add up to 180 degrees. And you can pick any of those straight lines. All of these angles add up to 180 degrees. Or I could pick this one. I know that's got to equal 180 degrees, so all of these. So now, what I like to do first is I like to get all my vertical angles. So it's a little bit more complicated, but you got to make sure you get the same line. So these two angles right here are vertical. So that means 40 is equal to angle 2. And you notice I'm not doing this in order, and very rarely do I answer these questions here in order. I like to take a look at the figure, and whatever kind of jumps out at me being the easiest, that's what I do first. So I know this angle here is 40 degrees. Well, I also know that this angle here, that's 120, is vertical to this one. Because remember, you have to go straight across. So 4 is also going to be, or not also, but 4 is going to be 120 degrees. So I can label that. So where it gets complicated is 3 and 1 are vertical angles, but I don't know either one of them. I know these two are going to be equal, so whatever 1 is, that's what 3 is going to be, but I don't know what they are right now. So what I'm going to do is think back to what I just said a couple minutes ago, that that's a straight line, so all of these have to add up to 180. So if I want to find angle 1, I just need to subtract 120 and 40 from 180. So this angle right here, I'm going to find by taking 180 minus 120 minus 40. Now you could also add 120 and 40 and then subtract that in one shot. I'm just going to do this, and that gives me 20 degrees. So I know this angle right here is going to be 20, and its vertical angle is going to be 20. That means these are both 20. So kind of a neat problem, sort of like a puzzle, but not too bad. Okay, the next topic. Angles formed by two parallel lines cut by a transversal. Now, we're going to have some fancy names for these angles here in a minute, but what I want you to notice, I mentioned this in the notes yesterday, one of the most important things in this course is to be able to identify acute and obtuse angles. So notice these two angles that I highlighted here. I'm hoping you all recognize as these angles as both being obtuse. Likewise, I could highlight this angle here and this angle here, and those two are both obtuse. Acute angles, well, that's acute, that's less than 90. So is this one. This angle's acute, this angle's acute. Basically what I end up having, 4 acute angles, I'm going to mark those with A's, and 4 obtuse angles. I'm going to use O's for that. So in this diagram here of two parallel lines, these are the two parallel lines, they never intersect, and this is called a transversal. It's a line that intersects both of them. So what I know is that all acute angles are equal. So this angle, this angle, this angle, this angle, whatever this one is, let's say that's 40 degrees, then all of these are 40 degrees. Okay, I also know all obtuse angles are equal. So whatever this angle is here, let's call it 100 degrees, well then that's got to be 100, that's got to be 100, and that's got to be 100. And there's one more thing that we need to know, and that is an acute angle plus an obtuse angle equal 180 degrees. So if I were to pick this acute angle and that obtuse angle, they add up to 180, which is easy to see because they form this straight line. But it doesn't matter which acute and which obtuse I pick. These two also add up to 180 degrees. So we've got two relationships we're going to have to keep track of. Are my angles equal, or do they add up to 180 degrees? So if I were to create a quick equation here, that would be angle O plus angle A equals 180 degrees. Okay, let's take a look at this example. We're going to go over some vocabulary here. I wouldn't lose a lot of sleep over this vocabulary. We're not going to quiz you on definitions or terms. We'd like you to know them, but really our goal in this course will be the application of those, whether you know they're equal or they add up to 180. So a transversal in this diagram, the transversal is the line that goes through and intersects those two parallel lines. So that's going to be line FE. Next, it asks for interior angles. Well, that word interior means inside. So inside would be in between the two parallel lines. So any angle or angles that are inside here are called interior angles. Well, we've got 4 of them. Angle 3, angle 4, angle 5, and angle 6. Those are my interior angles. And now exterior would be any angles that are on the outside of the parallel lines. So that would be the other 4. Angle 1, angle 2, angle 7, and angle 8. So that's the difference between interior and exterior. Okay, we're going to make a few sketches here. Types of angles formed by two parallel lines cut by a transversal. Alternate interior angles. So what we're going to do is I'm going to make quick sketches. I'd like you to do the same. Two parallel lines cut by a transversal. Alternate interior. That word alternate means on opposite sides. Sometimes you might even hear opposite interior or alternate interior. So the location of those would be here and here. This angle and that angle are alternate interior. One's on the left, one's on the right, and they're both interior. Now there's another pair. You guys probably figured that out already. So the same exact diagram, I could pick this one and that one. So there's two pairs of alternate interior angles. And one thing to remember, anytime I pick two alternate interior angles, they're going to be equal. So these two are always equal. These two are always equal. Okay, next we have what's called corresponding angles. And there's actually four of these, so I might want to draw these a little smaller. So one pair of corresponding angles would be here and here. You might pick up on this pattern as we go through. Another pair of corresponding angles would be here and here. We got two more pairs. Could be here and here. And lastly, could be here and here. Now again, these are all equal, meaning a pair of corresponding angles will always be equal. So notice how you get corresponding angles. This is like an intersection, and this angle right here would be the lower left. Well, if you think of this as another intersection, the lower left would be right there. So corresponding angles are in the same position. Lower left, lower left. Lower right, lower right. Upper right, and upper left, upper left. Interior angles on the same side of the transversal. So interior angles on the same side of the transversal. That'd be this one and this one. Now, those are not going to be equal. You can probably figure that out because if you just look at the shape, this shape is obtuse, that shape is acute. Or we could list them on the other side. Could be this one here and that one there. So the relationship here is that these are going to be supplementary. All right, so like I said, don't get too hung up on the vocabulary. I'm going to show you a method next for determining the relationship between two angles that are formed by two parallel lines cut by a transversal. And basically, you just need to know the difference between acute and obtuse, and if you know that, these are going to be very easy. So in this example, notice every one involves two parallel lines cut by a transversal, and I give you an angle measure, and I ask you to find x. What I want you to do, rather than think about, oh, are they alternate interior? Are they corresponding? Are they same side interior, same side exterior? That's way too much to think about. We're going to look at the shape of each angle. So first of all, you need to know this. This shape here equals acute. This shape here equals obtuse. You've got to be able to recognize those rotated, upside down, flipped. So in this diagram, example 4a, you need to recognize that the shape of this angle here is acute. Obviously, you can also tell because it's labeled 60 degrees, which is an acute angle. This one here, look at the shape. It's this, it's acute. So if both angles are acute, they are equal. There's not a lot of work to show, it's that simple. X equals 60 degrees. Okay, let's go to B. It's labeled 120, and you can tell by the shape, all right, it looks like this that's been flipped is obtuse. Then you have to look at this shape. Well, that's also obtuse. Looks like this one that's flipped upside down. So obtuse, both obtuse, means equal. So x is going to be 120 degrees. All right, letter C. This is obtuse, and this is obtuse. Obtuse and obtuse are equal. X equals 110. Now, before you start thinking, oh, these are all going to be equal, it really just depends on which two I give you, because notice in letter D, that angle there is obtuse. That's 100 degrees. This one here is acute. This shape is this. So if this is obtuse and that's acute, they cannot be equal. They are not equal. So if they're not equal, what they do is they add up to 180. So what we're going to do is we're going to say x equals 180 minus 100. That's going to be 80 degrees. Okay, a couple more. This one here is a couple ways you can actually recognize it. That's obtuse. Look at the shape, plus it's labeled 160. This is acute. These are also what we call linear pair because they make up this straight line here, which always represents 180 degrees. So if I want to find x, I'm going to take 180 minus 160, and that's going to be 20. And the last one, look at that shape. That's obtuse. Look at that shape. That's obtuse. So they're going to be equal. X equals 140. All right, one more application before we get into some equations, some algebraic applications. Notice here, I've got to find x, z, and y. And I know this angle here. So the first thing I like to do is identify this angle. Okay, well, that's 70 degrees. That's acute. So what are my other acute angles in this diagram? Well, that'd be x, that'd be y, and be this one here, which I don't really need. So this is acute, that's acute. Okay, so x equals 70 and y equals 70. Look at the shape of z. That is obtuse. That's not the same shape as this. That's less than 90. This is more than 90. So to get z, I'm going to use a different color. I'm going to take 180 minus 70. That's going to be 110. Okay, so I've got x, y, and now z. Okay, example 5b. The angle that's given to me is 110 degrees. So this is obtuse. So all my obtuse angles, they'd be this one, that'd be this one, and be that one. All my obtuse angles have to be 110. So that means y is going to be 110. Z is going to be 110. Now, if you notice x, that's acute. Look at the shape of it. The shape of this angle I'm highlighting. That's less than 90. So to get that one, to get x, I have to do 180 minus 110, and that's going to be 70. Guess I could have used different numbers here, but you get the idea, hopefully. All right, finally, let's wrap it up here. I know this is a long day of notes. I apologize, but it's very important. Find the value of x and then the measure of each angle in the figure below. So I don't give you numbers anymore. I represent the angles with an algebraic expression. So what we have to do is we have to look at the shape. This is the angle 2x plus 5. That's acute. Here's the angle 3x plus 15. That's obtuse. Look at the shape of those two angles I highlighted. They're not the same. So what that means then is I have to add these two together and set it equal to 180 degrees. Okay, so 3x plus 15 plus 2x plus 5 equals 180. So notice all this stuff here is on the same side of the equal sign, so I'm going to combine like terms. I'm going to combine 3x and 2x. That's going to give me a 5x. I'm going to combine 15 and 5, and that's going to be a 20. So I've got 5x plus 20 equals 180. Subtract 20 from both sides. 5x equals 160. Divide by 5. Probably want a calculator here. That's going to give me 32. So I want to circle this because it says find the value of x. That was part of the direction. So got that. Now it says find the measure of each angle in the figure? Well, there's not just 2 angles, there's 8 angles. I gotta find all of these. Now there's only 2 different angle measures, but I have to label the diagram. So maybe over on the side somewhere you might want to plug in, let's find this 2x plus 5. So let's do 2 times 32 plus 5. So I'm finding this one here, which is the acute angle, which means all my acute angles are going to be the same. Well, if we throw that into the calculator, that gives me 69 degrees. So I'm just going to label it in my figure. This angle is 69 degrees, so is this one, so is this one, the acute angles, remember, and so is that one. Now to find the other angles, 2 ways you can do it. You can take this 32 and you can plug it in right there and do 3 times 32 plus 15. Or remember, hey, straight line equals 180. So now I can just take 180 minus 69, and that's going to give me all my obtuse angles. So I think that's what I'm going to do. 180, sorry, messy, minus 69, that's going to be 111. So that angle is 111, that's 111, and those two are both 111. So kind of a challenging example, probably one of the harder ones we'll do in the entire unit, to be honest with you. All right, so this will be a little bit challenging for me scrolling up and down, but basically we've got one diagram here that we're going to use for all of these questions. So in part A, it gives us the measure of angle 1. So that's this one here. Clearly it's acute, it's 35 degrees, and by the shape of it, it's also acute. I want to find the measure of angle 6. There's angle 6. So the question you have to ask yourself, well, is this angle I'm highlighting acute or obtuse? Hopefully you can recognize that shape as obtuse. So if it's obtuse, it's not going to be equal to 35. So what I need to do here is I need to take 180 minus 35. This can give me 145. That's going to be the measure of angle 6. All right. Part B, measure of angle 3 is this. Measure of angle 6 is this. Without looking at this, so pretend I don't have that. I have no idea. I have no idea how to do this. You must use the diagram. So angle 3, look at the shape. Hopefully you recognize it. That's obtuse. If you want to make a little note down here, that's obtuse. Measure of angle 6. Okay, we're 6. 6 is here. Look at the shape. Oh, that's also obtuse. Okay, you don't have to do this, but sometimes it helps. So if they're both obtuse, guess what? They are equal. So I'm going to take this and set it equal to that. Okay, so 3x minus 20 equals 2x plus 5. And again, we're seeing this for the second time today. If your variables are on opposite sides, you want to take the smaller one. Oops, sorry about that. You want to take the smaller one and move it to the other side. So I'm going to take that and move it over here. So I'm going to subtract 2x from both sides. So I get x minus 20 equals 5. Now I'm going to add 20 to both sides. And I get x equals 25. Now what do the directions say? The directions say find the value of x. So I just have to circle that, and we're done. Okay, last two. Whew, thanks for sticking with me. I know this is a little bit challenging. Most of them are not even be close to this long. So measure angle 4. Find it in the diagram. Measure angle 4 is right here. Trace it. That is acute. Okay, so that's acute. And measure angle 6, I think we already talked about 6, that is obtuse. So notice, if one's acute and one's obtuse, they are not equal. So now we're going to have to add them up and set that equal to 180. Okay, so x plus 18 plus 2x equals 180. Combine my like terms, I get 3x plus 18 equals 180. Subtract 18. 3x equals 162, I believe. Divide by 3. I better double check this on the calculator. And I get x equals 54. So this is kind of tricky. This says angle 4. This says angle 6. This says find the measure of angle 5. what? So what I need to do is I need to go up to the diagram and look at angle 5. Angle 5 is either going to be the same as 4 or it's going to be the same as 6. And I got to pick which one of these to plug in my value of x. So angle 5 is acute. Clearly 6 is not, but 4 is. So that's acute and that's acute. So now what I want to do is take my value of x here and plug it into that expression. So I'll use a different color. Measure of angle 5 is going to be 54 plus 18. Again, you want to throw that into the calculator, and that gives you 72. Okay, finally, we made it. Last one. Measure of angle 1 is here. That's acute. And measure of angle 5 is here. That's also acute. Find the measure of angle 1. All right, so my equation, they're both acute. They're going to be equal. All right, so let's do this. 12x equals 3x plus 45. Subtract 3x to move it over. 9x equals 45. Divide by 9. X equals 5. Find the measure of angle 1. Well, this one's easier because there's angle 1 right there. So to plug in, that's going to be 12 times 5, which is 60 degrees. So that's a lot, guys. I appreciate you sticking with this video all the way to the end. Please, if you need to, pause, rewind, go back, fill in the notes. Don't hesitate to do that. And also don't hesitate to contact me if you have any questions. All right, we'll see you in class soon. Thanks again. Have a great day.